This tutorial will show you how to use an ultrasonic distance sensor to calculate the distance of an object from the sensor, and then we're going to use that information in a couple of different ways. To start off, you can see I've got my breadboard set up and my 5-volt run to my positive and my ground is run to my negative. Let's drop in a sensor, but under the basic components we're going to see that we have a 3-pin sensor. I actually would rather use the 4-pin. I find those easier to work with. To find that, you click on up here to all, and then we're going to scroll down to our 4-pin sensor, and I'm just going to drop that in right here. If you hover over these 4 different pins, you can see the first one on the left is power, then we have a trigger, that's our output pin, echo, which is our input pin, which is going to sense the echo of the ultrasonic kind of sonar thing off the object when it bounces back in, and then our ground. So let's go ahead and connect our hot and our cold with a red and a black. And oops. Then we need to run our trigger, which is our output. I'm going to make that digital 2 and make that orange. And then our echo, I'm just going to run to digital 1. That's our input, and I'll make that purple. Next, I'd like to plug in a few LEDs. We're going to do the old stoplight setup that I like so much. So we're going to do red, yellow, and green. And if you think about maybe if you were going to use this as something in your garage that when you're backing in your car to tell you when you're getting close to the back wall and then when you're about to hit the wall. So green will be kind of our far distance, yellow will be our medium distance, and red will be our close distance. I'm going to run our green to number 5 from our anode. Let's make this yellow just for clarity, and then red over to 7. Okay, so those are all looped in with circuits as well as this. Okay, so let's take a look at our code. Since we have so many different connections, we're actually going to use this define function to set some things to make it easier so we don't have to remember which port we're in. We can just use different terms. So we can see our trigger is going to number 2. So our trig pin is going to be 2. Oops. Our echo pin is going to be 1. And let's just call green is going to be 5. Yellow is 6. Whoa. And red is 7. Okay, so now we can just use these terms instead of our port numbers there. We also have to set 2 variables up here. Our duration, which is going to be the length of time it takes for the sound that we create from our sensor to bounce off the object and return. And we just use the long function for that, so that's going to be duration. And then we're going to actually convert that duration into a distance. So we're going to set up that variable here as well. We have to close these off with these semicolons too. Oops. Then we move on to our setup. And we need to define all of our inputs and outputs. So we use the pin mode function for that. And we know that pin mode, let's see, our trig pin is going to be an output. Let me just copy and paste. This might save us some time. Oh boy. Our echo pin is actually our input. And then green is an output, yellow LED is an output, and our red LED is an output. Okay, and that's all we need to do for our setup. Now let's do our loop. So the first thing we're going to do with our loop is we're going to send out an audio signal. So we want to make sure first of all that our sensor is off. So we're going to make sure that it's in a low power state. Then we're going to send an audio signal for a very brief duration of time. It's going to be 5 microseconds. So off and then on, beep, and then we're going to turn it back off again. To do that, we're just going to use our digital write function. And that's going to be our trig pin. And we're going to make sure that's low state to begin with. And then just so that it doesn't, go immediately, we're going to delay briefly. Oops, we've got our open bracket there. Let's add that in. We're going to delay microseconds, and we're just going to make that 2. Then we're going to write, oh man, I can't type today. We're going to write that trigger pin to a high power state for 5 microseconds. And then we just need to turn that pin off again. So we're basically sending a pulse of ultrasonic sound with that function right there. Okay. Next, we need to listen to our echo pin. To do that, we're going to use our duration variable. So the duration is going to be equal to pulse in. Okay, that's our command. And then we're listening to the echo pin, of course, listening for that echo pin. And when it turns into a high state, that means it's receiving the sound. Okay, so our duration is going to be equal to the length of time it takes for that pulse to come back to it, and that'll be in microseconds. Okay, so now we've got the distance, how long it took the sound to bounce off the object and come back. Now we need to change that into distance. So our distance is going to be equal to our duration, and then we have to do a little bit of math. Okay, our math is going to be based on the speed of sound. Oh, the speed of sound is 343 meters per second, but we want to change that to something more usable with our microseconds, so we could do that in centimeters. Or if we wanted to use freedom units, we've got our speed of sound in inches per second, but we need to convert that over to microseconds. Okay, and basically we've got these two fractions. We've got 1 over 29.1, our distance over that to calculate for centimeters, or 1 over 74 for inches. The problem with this is that our sound is coming out of the sensor, it's bouncing off the object and coming back. So this is actually twice as far as the actual object. To make the calculation, we need to cut that in half, right? We want half the time, which will give us our actual distance. To do that, all we do is multiply the denominator by 2. So if you want to do centimeters, you just divide the distance by 58.2. If you want to use inches, you divide by 148. Since I'm American, I'm going to use inches. So just jump back to our code, and our duration divided by 148, semicolon. Okay. Now that we have that duration, the distance, now we can do a few things with that. So we're going to use our if-then statements. So if the distance is greater than 8 inches, our then is just simply opening up a bracket, and we're going to digital write our green. It's going to be high, close that bracket, digital write yellow, it's going to be low, that one's going to be off because this is far away, and our red will also be low. We've opened a bracket, so we close that bracket. Okay. Now let's just copy and paste this. We're going to do 2 more instances, right? So this will be our medium distance here, and then we'll use this for our close distance in just a moment. So for our medium distance, we want it to be less than or equal to 8, and distance is greater than or equal to, let's say 4 inches. Okay. In that case, our green is going to be off, so we'll write that low. Our yellow will be high. Finally, if our distance is less than 4 inches, our green is going to be low, our yellow is going to be low, and our red will be high. Okay. After all that, since we don't want to kind of overload our system, we'll add in a little delay here of 50 milliseconds just to give us that. And then last thing we need to do with all of this is to close our overall bracket for our void loop. Okay, let's start the simulation and see what happens. Okay, so if we click on that sensor, we can see that it's telling us, you know, in the simulation what those measurements are. Since we're over 8 inches away, our green LED is lit. As I drag it closer and closer and closer, once we get under 8 to 8 inches, our yellow changes there, and once we get even closer to our 4 inch, under 4 inches, our red goes. Okay, so if we were again backing into our garage, we've got that. Okay, it might be kind of hard for us to see these things. Okay, so one other thing we can do is we can add in a buzzer. So I'm going to scroll down and find a Piezo Buzzer, and we're going to drop that in. I'm going to bring my negative to the negative side with a black wire, and I'm going to run a positive one over here to number 4. Let's just jump back into our code, go back to the top, and let's define that as buzzer, no E. Buzzer is going to be number 4. We also in our setup have to set that, so pin mode buzzer will be an output. Okay, and then the command that we're going to use for this is creating a tone. So we want it to make a tone when it's very close. So we're going to add a tone here, and that's going to be our buzzer, B-U-Z-Z-R, and then we can tell it what our frequency is, and we're just going to make the frequency 1000 Hertz. Okay. So now when we get to that red state, beep, the buzzer will go off. But we also want to make sure that it does not go off in these other 2 instances. And the language used there is just no tone. And we just specify that's going to be our buzzer. Okay, same thing here. Let's just copy and paste. So we're telling it there's going to be no tone on our buzzer, no tone on our buzzer, but then we do have a tone, and it'll be 1000 Hertz. You can pick any, you know, hertz you want there. It can be A440, whatever note you like. Okay, so let's check that code. Oh boy. Oh, we forgot a semicolon there. Try again. Looks clean. So we're here. Okay, so hopefully you could hear that buzzer going off and see it, so that works. So that would be a nice thing to have as we're backing in. We could be listening for that buzzer. So hopefully that was helpful to you. I had to talk fast because I wanted to keep this video short. If you need to go back and listen again, you can. Or if you're confused on any of the code, you can also look at some of my other code tutorials. Next up, I will show you how to wire this and make it in actuality.